Hello everybody, getting ready to do lesson 8.8 part 2 classwork for pre-algebra math. And on your classwork sheet you got 20 points, have that out ready to go. Put your name, date, period here on your Droid, your phone, your tablet, your Chromebook. And this part 2 is systems of linear equations. Going to page 1 here of our lesson today. Example 3, solving a linear system with many solutions. So we're going to solve this linear system here. 2x minus y equals -3 is equation 1. And then -4x plus 2y equals 6 is equation 2. So to solve this linear system, start with writing each equation in slope-intercept form. So equation 1 up here, we got to isolate our y over here. So we got to move our x over. So we have -y equals -2x minus 3. And then we got to get rid of this -1, so we multiply through by -1. And we end up with y equals 2x plus 3. There's our slope-intercept for equation 1. And then same thing for equation 2. We got to isolate our y, so we move our x over. Then we divide through by 1/2, or we multiply through by 1/2. And we end up with y equals 2x plus 3. So now both are in slope-intercept. But what is going on here? Slope-intercept forms of equations 1 and 2 are identical, so the graphs of the equations are the same line. So shown here, right here's the line for both of these equations. Y equals 2x plus 3. We have a y-intercept of 3. We have a slope of 2. And then we have our x-intercept down here, which is what, 1.5 is for x. So anyway, they both have the same line. So because the graphs have, these two graphs have infinitely many points of intersection, this system has infinitely many solutions. Any point on the line y equals 2x plus 3 represents a solution. So let's try in our guided here. Let's try one out here. Solve the linear system by graphing. We have x minus y equals -3, and then -4x plus 4y equals 12. So we're going to use the same method. We're going to put both these in slope-intercept form. And so x minus y equals -3. We're going to solve for y, move our x over, multiply through by -1. We end up with y equals x plus 3. The same thing here. We move our 4x over, then we divide through by 4, and we end up with the same thing. Y equals x plus 3. Therefore, here's our line. Same line for both equations, so therefore the system has infinitely many solutions, infinite amount of solutions. Let's go into another example here. Example 4, writing and solving a linear system. A company offers two plans for high-speed internet service. Plan A, you can pay $200 for the modem and $30 per month for service. And then Plan B, the modem's free and you pay $40 per month for the service. So part A, after how many months are the total costs of the plans the same? So okay, part A, let y be the cost of each plan after x months. Then write a linear system. So plan A up here, plan A is y equals 200 plus 30x. That is your cost function there for plan A. And then plan B is y equals 40x. So here we have our two equations here, A and B. So here they are here. Here is plan A. Here's the line for plan A. And then here's the line here for plan B. And they intersect. Use a graphing calculator to graph the equations. Here's a screenshot. They intersect here when x equals 20, y equals 800. So trace along one of the graphs until the cursor is on the point of intersection, which is right there. And this is point 20, 800. So Okay, Okay, so now that we have our equation A, equation B, the total cost of the plans are the same after 20 months, which is right there, when each plan costs $800. So at 20 months, both these lines intersect. A and B intersect at 20 when X equals 20. So the graph for plan A lies below the graph for plan B when X is greater than 20. So here's plan A, and it's below plan B for costs after 20 months. So plan A costs less if you have service for more than 20 months. And then when is plan A a better deal? When is plan B a better deal? So the graph for plan B lies below the graph. Here's plan B here, the blue line. Below the graph for plan A when X is less than 20. And so plan B costs less if you have service for less than 20 months. So let's try in our guided up here. We got a word problem. A business rents inline skates and bicycles to tourists on vacation. A pair of skates rents for $15 per day. A bicycle rents for $20 per day. On a certain day, the owner of the business has 25 rentals and takes in $450. Use the verbal model below. Write and solve a system of equations to find the number of each item rented. So we have rent per pair of skates times pair of skates plus rent per bicycle times number of bicycles equals total income. So what are we going to do to solve this here? And then down here for your independent students, you're going to find how many skates and bicycles were rented. So we're just going to find up here the total income here. So to do this up here for part A up here, what we need to do is let X equal the number of pairs of skates and let Y equal the number of bicycles. So X plus Y equals 25. So he had the total rentals of 25. And then solving for Y here, Y equals negative X plus 25. So there we solve for Y. So for Y here, we plug in Y here in our 15X plus 20Y equals 450. So we have 20y equals negative 15x plus 450 when we solve for y. And then we divide through by 20, and we get negative 3/4x plus 22.5. So once we have a y here, we have a y up here, then we have a y down here. So this is our blue, and then this is our red. What do we do with that? So this is where the lines intersect when x equals 10, y equals 15 on each of these. When we plot both of these on your graphing calculator, you'll get a point of intersection here at x equals 10. So using a right system of equations to find a number of each item rented for that. So if we put that in, the solution is 10, 15. So the owner rented 10 pairs of skates and 15 bicycles on that one. Because up here we're solving for the number of bicycles, and then down here we're solving for the number of skates. And so when the owner rented 10 pairs of skates and 15 bicycles, that gave us an income of $450. And that's your lesson for today. Animated PowerPoint math video at AOL.com for questions or course materials. Thank you very much.